The James Webb Space Telescope has reportedly spotted galaxies dating even further back.
We expect James Webb to make great discoveries. We expect that.
The James Webb Space Telescope has made a discovery that challenges the fabric of our universe. This recent discovery has piqued the interest of astronomers and scientists and suggests a potentially colossal event that might transform the universe as we know it. Could this discovery lead to the end of all we know? Is the universe on the brink of a transformative event beyond our current understanding? Join us as we explore the latest discovery of the James Webb Telescope and how it could destroy the universe. When we examine the universe's edge, we begin with the observable universe. It's like seeing through a window into the expanse beyond. The observable universe includes everything we can now detect, measure, and examine with our telescopes and space missions. It is a collection of stars, galaxies, and celestial bodies that are visible to us. The difference is that the observable universe is just a portion of the whole cosmos. See it as a little piece of a massive cosmic pie that humans can study and understand. But the overall size and form of the universe remain a mystery. The diameter of the observable cosmos is roughly 93 billion light-years. This figure is the result of various factors. The distance that light can travel in one Earth year is 9.46 trillion kilometers, 5.88 trillion miles, in a light year. A light year is the distance traveled by light, the fastest thing in the universe in 1 year. The estimated age of the universe since the Big Bang is 13.8 billion years. This means that light emitted by objects in space that humans can see has been traveling towards Earth for no more than 13.8 billion years. That implies that the observable universe is 13.8 billion light-years in every direction from Earth and 27.6 billion light-years in diameter. However, Hubble's law states that space has been expanding since the Big Bang, and hence the observable universe has been expanding as well. Estimates of this expansion indicate that objects that emitted light 13.8 billion years ago from a distance of 13.8 billion light-years distant are now even farther away from Earth, approximately 46 billion light-years away. This shows that the observable universe extends more than 46 billion light-years in every direction from Earth and has a diameter of around 93 billion light-years. So when we say the observable universe's diameter is 93 billion light-years, we're talking about an unimaginable span of approximately 54,684,568 light-years. The cosmos came into existence 13.8 billion years ago in an extremely powerful explosion. This explosion initiated what we now refer to as the cosmic expansion. Since that historic moment, the universe hasn't just been expanding, but has also been accelerating. Enigmatic forces like the mysterious dark energy seem to be driving this acceleration, pushing the universe's limits further and further apart. Matter began to form under the pull of gravity as the cosmos expanded. This gravitational attraction pushed particles together, resulting in the formation of amazing structures such as stars, galaxies, and eventually planets like our own beloved Earth. Given the universe's constant expansion, the observable cosmos grows by another light-year every Earth year. At the same time, light from farther objects continues to reach Earth for the first time. This implies that humans are seeing more and more of the cosmos as time passes. While humans will never be able to observe the entire cosmos from Earth, the field of observation is constantly growing. Technologies that capture and process electromagnetic radiation outside of the visible spectrum allow humans to discover and view distant individual galaxies, clusters, and superclusters in the observable universe. Specialized telescopes such as radio telescopes, X-ray telescopes, ultraviolet telescopes, infrared telescopes, and others, have been beneficial in this regard. The well-known Hubble Space Telescope and James Webb Space Telescope enabled visualization of the first stars and galaxies that originated in the visible universe. This makes these wonders more accessible to the general public. Despite its vastness, the universe is oddly empty. Even if we reduce our whole solar system to the size of a quarter, the nearest star would still be around 2 soccer fields distant. This grandeur extends just inside our own Milky Way galaxy, which is one of billions in the observable universe, giving us a sense of the cosmic size. You may be wondering why we can't simply see everything in the cosmos. There are a number of reasons for this restriction. To begin with, even though light is the fastest object in the universe, it still takes time to travel through space. This means that when we look at distant objects, we are basically gazing back in time. The farther away an object is, the longer its light has traveled to reach us. It's like looking through a cosmic time machine, unraveling the history of our universe as we witness galaxies millions, if not billions, of light years away. However, there is another component at work here. The cosmos is expanding. Think of the surface of an inflated balloon as being covered in dots. The dots travel apart from each other as the balloon grows. The cosmos follows the same principle. Galaxies, like those dots, drift away as the fabric of space expands. The light emitted by distant objects undergoes a modification known as redshift as a result of this expansion. Light wavelengths are stretched when objects move away towards longer wavelengths, which are commonly seen as a reddish tint. Some celestial bodies eventually pass beyond a crucial distance, known as the cosmic horizon, when their light is just too far away to reach us due to the universe's expanding nature. Given these two major factors, the light's travel time and the expansion of the cosmos, it's not surprising that we haven't seen the entire universe yet. Even with the most modern telescopes and technology, our vision remains restricted by the fundamental features of the universe. Let's delve a little more into these concepts. The universe's size is amazing. Scientists use measures like light years to indicate the distance that light travels in a year. It is about 5.88 trillion miles, or 9.46 trillion kilometers. Our galaxy, the Milky Way, is around 100,000 light-years across. Even inside our galaxy, the closest star to our Sun, Proxima Centauri, is around 4.24 light-years distant. When we look into space, we can see galaxies billions of light-years away. This means that the light we see from those galaxies began its trip billions of years ago, giving us a look into the universe's early history. The attempt to understand the universe's possible edge or bounds has drawn the attention of numerous individuals from various fields. While definite solutions continue to elude us, 3 significant ideas have developed, each giving unique views on the vastness of cosmic space. The first theory posits that the cosmos is eternally long, with no visible end point. This idea fits in with the cosmological principle which states the universe's isotropy, its uniformity in appearance from every vantage point. If this concept is true, it means that the cosmos has no boundaries and can expand forever in all directions. The second theory provides an alternate viewpoint, arguing that while the cosmos may be finite, it lacks a clear-cut edge. Instead, it is compared to a massive spherical or curved space comparable to a globe. In this scenario, if one were to travel in any direction indefinitely, they would ultimately return to their starting point, similar to circumnavigating the Earth. The third theory, the multiverse concept, provides the intriguing idea that our world is merely one among many. Consider many worlds, each with its own set of physical rules, constants, and attributes. These universes might be completely different and operate independently from one another. Alternatively, they might be linked together by complicated systems to build a huge and intricate multiverse. Exploring these theories piques both scientific and philosophical interest. The concept of an endless cosmos challenges our perceptions of space and our comprehension of its vastness. On the other hand, a finite universe without an edge challenges our concepts of boundaries and continuity, offering the potential of cyclical patterns within the fabric of space. The multiverse theory, with its parallel worlds, provides a rich environment for research, indicating the existence of realms quite distinct from our own. If true, it could mean that changes in physical rules and fundamental constants can give rise to whole new forms of existence, opening up a world of possibilities beyond our recent understanding. However, these concepts remain theoretical and elusive, as investigating the universe's edge involves huge obstacles. It is hard to conclusively validate or deny these theories because of the immensity of cosmic space and the limits of our existing observational instruments and technology. The discovery of the universe's edge has been an exciting adventure rich in theories and thoughts. However, one game-changing tool, the James Webb Space Telescope, JWST, stands out as a beacon of hope, shedding light on the mysteries that cloak the cosmic beginnings. This unique tool has an unrivaled potential to uncover our universe's cryptic history, allowing us to gain insight far beyond what was previously imagined. The JWST is a technical wonder, specifically developed to view the universe with incomparable accuracy. Its outstanding features allow us to see into the beginnings of the cosmos. The JWST has discovered 6 massive galaxies that date back between 500 million and 700 million years after the Big Bang. This is according to a recent research published in the Nature magazine. Surprisingly, these ancient galaxies defy predictions, with diameters substantially greater than expected for their age. These surprising discoveries cast doubt on accepted theories on the origins and development of galaxies in the early cosmos. Astronomers initially expected to see tiny, fledgling galaxies during the telescope's observations. Instead, they were astounded to discover these gigantic cosmic creatures, which altered the story of cosmic evolution. The maturity of these old galaxies is simply mind-boggling in these observations. Contrary to popular belief, these cosmic giants have reached the same degree of development as our 13-billion-year-old Milky Way galaxy. The sheer size of the stars within these galactic behemoths is beyond understanding, with each possessing a total mass several billion times that of our Sun. Surprisingly, one of these galaxies might have a stellar mass up to 100 billion times that of our Sun, dwarfing the massive size of our Milky Way, which has a stellar mass of about 60 billion suns. The JWST's unmatched capacity to observe the universe's secret regions is based on its use of infrared light, which is invisible to the human eye. This incredible capacity enables the telescope to detect feeble emissions from old stars and galaxies, revealing cosmic remains that have lasted billions of years. The JWST is a time machine, sending our vision back through the eons. It provides a priceless insight into the cosmos as it existed around 13.5 billion years ago, rewriting the cosmic tale. The recent discovery of vast galaxies called universe breakers has revolutionized our understanding. It's a surprising twist that questions 99% of the models we had developed for early galaxies. We used to believe that galaxies started from humble beginnings as small groups of stars and dust. They were thought to evolve gradually over eons, increasing in size and complexity. However, the universe breakers countered these beliefs when the James Webb Space Telescope data and high-resolution photos revealed these massive galaxies. Scientists were taken aback in July 2022 when these behemoths appeared abruptly, almost as if asking to be discovered, challenging our previous knowledge of galactic development. Furthermore, scientists used spectroscopic methods to examine light at different wavelengths. This research holds the key to unlocking important facts about these mysterious galaxies, such as their composition, size, and distance from Earth. This discovery is even more intriguing because it was not the major goal of the James Webb Telescope's research. It appeared suddenly, exceeding all expectations and developing quicker than predicted. A further mystery to the cosmic fabric is the possibility supermassive black holes lie underneath these galaxies. Even when only a quarter of the data is taken into account, the known mass of stars in the cosmos may now be up to a stunning 100 times more than our prior estimates. This discovery suggests an essential reassessment of our understanding of cosmic mass and structure. Each new discovery adds to our cosmic map, offering a more detailed picture of the universe's history and evolution. The implications of these massive galaxies extend beyond their size. They call into question fundamental ideas, prompting us to reconsider our fundamental understanding of cosmic development. The amazing discoveries made by the James Webb Space Telescope have advanced our understanding of the cosmos to unparalleled heights. This cutting-edge telescope made an incredible discovery. It identified the oldest and most distant galaxies ever viewed. These galaxies take us to a period when the universe was only a fraction of its present age, surviving only 400 million years after the colossal event known as the Big Bang. What's truly fascinating is that the light emitted by these galaxies began their trip over 13.4 billion years ago, finally reaching our detection through the JWST's lens. The telescope's earliest pictures echoed the Hubble Space Telescope's early glances, revealing many possible galaxies. Despite this, astronomers were able to confirm 4 of these celestial phenomena through sophisticated spectroscopic examinations. This allows for a full study of their physical features and exact measurement of their distances from us. How can astronomers determine the distance between galaxies? Here comes the idea of redshift. Celestial objects appear to recede from our perspective as the universe expands, causing their light waves to stretch out and shift towards longer wavelengths, a process known as the Doppler effect. While photographs captured via various filters can provide estimates of redshift, spectroscopy emerges as the favored approach for getting precise measurements by dismantling the object's light into its constituent wavelengths. Let's dive into these amazing discoveries, focusing on 4 galaxies with redshifts greater than 10, showing their incredible distance from us. To put this in context, the Hubble Space Telescope previously discovered 2 of these galaxies with redshifts of 10.38 and 11.58. However, the JWST's visual prowess revealed 2 much more distant galaxies with redshifts of 13.20 and 12.63. A redshift of 13.2 effectively implies a time frame of 13.5 billion years ago, providing us with an exciting view into our universe's past history. The James Webb Space Telescope's Advanced Deep Extragalactic Survey, or JADES, provides proof of the telescope's ambitious aims. This program has been given a month to probe into the depths of the early cosmos, with the goal of providing an unsurpassed comprehensive view into the universe's beginnings. JADES started off as an idea in 2015, offered by a group of instrument teams. This cooperation gave birth to the worldwide collaboration JADES, which brought together around 80 astronomers and scientists from 10 different countries. Their group's objective is to embark on a massive exploration of the universe's early phases, unraveling mysteries that have persisted for eons. JADES has been carrying out an ambitious program of deep infrared imaging and multi-object spectroscopy in the Hubble Deep Field, GOODS-N, and Hubble Ultra Deep Field, GOODS-S, using 3 JWST instruments. JADES is the biggest program in JWST Cycle 1, with almost a month of mission time. It is the result of a partnership between the Near-Infrared Camera, NIRCam, and Near-Infrared Spectrograph, NIRSpec instrument development teams, as well as a minor contribution from the MIRI US team. JADES is taking NIRCam imaging in 8 to 10 bands, spanning around 45 square arc minutes to extremely deep limits, fainter than 30th magnitude, with an average of about 130 hours of total exposure time, and another 175 square arc minutes to a normal exposure period of 20 hours. JADES then conducts extensive NIRSpec spectroscopy on over 5,000 targets on 31 different pointings, including 2 of remarkable depth, 55 hours spaced over 5 dispersers. These offer stunning images of these faint galaxies. The initial part of the JADES program concentrated on NICOM, devoting more than 10 days of precious mission time to scrutinize a limited portion of the sky, especially containing the Hubble Ultra Deep Field. For almost 20 years, astronomers have focused their attention on this specific location, using several huge telescopes to try to solve its mysteries. However, by methodically investigating this field over 9 separate infrared wavelength bands, the JADES team discovered a fabric of roughly 100,000 distant galaxies, each billions of light-years away. Following that, equipped with the NIRSpec spectrograph, the scientists set out on a 3-day observation mission, catching light produced by 250 faint galaxies. This strategic decision allowed for a deeper dive into the substance of these galaxies, revealing the complex features of the gases and stars that resided within them. Furthermore, these observations allowed the acquisition of exact redshift values, which are crucial in determining the placements of these galaxies in the vast cosmic landscape. These observations are keys to unlocking critical information about these faraway galaxies, providing insights into the galaxy's inherent brightness and providing estimates of the amount of stars within them. Such discoveries open the door for a comprehensive research of the development of galaxies spanning cosmic timescales. Even if first-hand knowledge of their early phases remains obscure, investigating galaxies can be as difficult as comprehending humans. The first stars have a major effect on the fate of galaxies, similar to how our early experiences affect us. This period is unique in that the Webb Telescope's revolutionary capabilities are answering numerous galaxy-related questions. NASA's Deep Space Observatory Telescope, the James Webb Space Telescope, is revolutionizing our understanding of the cosmos. It is revealing various new findings, including new data on supermassive black holes. Thank you for watching another episode of Voyager. While you are still here, click on the video on your screen to see more mind-blowing videos like this one.